So how do we use these definitions of the trigonometric functions in practice? Like, if we just wanted to take the sine, cosine, or tangent, or cosecant, secant, or cotangent of some angle theta, then how do we use these definitions to find what those values would be? Well, we sort of fall into two scenarios. Here. One scenario is if the angle that we want to take the sine, cosine, tangent of is one of these common angles, so it's either pi over 3, pi over 4, pi over 6, or an integer multiple of these guys, an integer multiple of one of these three. So, for instance, 7 pi over 3, 5 pi over 4, 3 pi over 4, etc. If the angle that we want to take the sine, cosine, or tangent of falls into this category here, then we use a reference unit circle. And this reference unit circle will look something like this. I'm just going to draw the top right quadrant, so the first quadrant of what a reference unit circle might look like. And you can just Google this or look in your textbook for a reference unit circle. I'm just drawing the first quadrant. So this reference unit circle will have, say, pi over 6, pi over 4, and pi over 3. And then they'll have the xy coordinates of these guys. So what I mean by that is, if I were to walk around the unit circle pi over 4 radians and stop, then the xy coordinate of this point at which I stop will be written down in this reference unit circle. They'll tell us it's, in this case, it's square root of 2 over 2, comma square root of 2 over 2. And I strongly, strongly encourage you, at the very least, to memorize the top right quadrant of the unit circle, this top right quadrant right there. I strongly recommend that you memorize. So both the xy coordinates of the angles. So what I mean by that is, I strongly recommend that you memorize these points right here. The point where if you were to walk pi over 4 radians and stop, I strongly recommend that you memorize what those xy coordinates are. The same for pi over 6 radians and pi over 3 radians, because these angles show up all the time. So if I wanted to take the sine of pi over 4, then I take the y coordinate of this point, and that just how happens to be square root of 2 over 2. So that's what we do when we get one of these typical common angles that show up all the time. So if we're given an angle that doesn't fall into this category of one of these typical angles, then we sort of have a second scenario that has two sub-scenarios. And one of the sub-scenarios is we just use a calculator. And we're careful to set that calculator to degrees if we're taking the sine, cosine, or tangent of an angle measured in degrees, and then radians if that angle is measured in radians. And one nice calculator to use is Wolfram Alpha, and that's an online calculator that's free. You just search Wolfram Alpha in Google, and you go to the Wolfram Alpha page, and you can type in, for instance, sine of 17 space rad if you want to take the sine of 17 radians, and you can type in sine of 17 DEG if you want to take the sine of 17 degrees. And the other sub-scenarios, we're clever with our use of trig identities. And I'll talk about this more in future videos, but to give you a sort of advertisement of what this means, and what I mean by this is, if we're given, say, the sine, cosine, or tangent of, if we're asked to find the sine of an angle theta that doesn't fall into this category over here of one of these common angles, and we could rewrite this as, say, the cosine plus other stuff, the cosine of angles that do fall in to this category, the cosine plus, or it could be times, or anything. We rewrite sine of theta in the form of cosine, sine, tangent, cosecant, secant, or cotangent of angles that do fall into this category.